Hey, hello, Ron. Good morning. Can you confirm audible or not?
Yeah, we can
Can you hear
hear
me?
you. Yes, we can hear you, sir.
Yeah. So, can you hear me? So today's our topic is like the maths concepts. What kind of, okay? That means which concepts we are going to use. Okay, in your data science. For example, you are like a data scientist. While working with the data, while analyzing the data, okay, most of the times, what kind of concepts, mathematics concepts we are going to use in data science, we are going to discuss. Okay, it's like a high level. Okay, the first one is like, right? Okay, last session we discussed about the terminology wise, ML, machine learning. The next one is like DL, deep learning. The next one is like AI. The next one is like DS, data science. So if you see this definitions wise, okay, first one is like, let's start with frequently used terminology, ML, machine learning. Okay, now, can anyone tell me why we go for, okay, when you can go, okay, machine learning models? Models is nothing but just one program you are going to write. Okay, that program is going to read your existing data and predict the future one or not. Okay, just I have some data is there, my machine learning model. Okay, don't think like model is nothing but something else. It's a terminology wise we can say like a model. It's also one kind of program only. Sometimes we say like algorithms also. Okay, don't think more, it is also simple one program only. Okay, in that program, whatever you have the data in the past, I have this much data. Okay, it is going to read the data and understand the data and predict the future. Predict the future. Okay, now can anyone tell me one simple example for this particular ML? Simple example to this particular ML. Very simple. Okay, last 5 years, okay, my business, okay, in different areas like this. Last 5 years, okay, my business in different states, for example. Okay, in 5 states, okay, something like this. The state one, okay, last year this much. Okay, before that this much. Last 5 years, okay, in 5 states my business is like this. Now with this data, can I predict the next year how the business is looks like? Can we predict with this data? We can just assume it's not like exactly it's like this year, not like that. But by reading this data, by analyzing this data, by understanding this data, I can assume, I can predict the future or not. Yes or no? Okay, last 5 years at this particular, okay, month, okay, there has some cyclones. Okay, now this year there may be a chance, by seeing that particular data, there may be, okay, the chance of getting the cyclones. Okay, how I can assume it is may come, may not come, but just I can predict or not. Last 5 years in this particular month happened like this, there may be a chance, okay, in this year also. Okay, based on previous data, if it is there, okay, there, if it is not there, not there. But it is a kind of, not exactly, it is a prediction, it is a prediction. Okay, ML models we are going to use for what? Okay, read the existing data, read the current data. Okay, read some data. Okay, read some data, analyze it, understand it, and predict it, okay, for future purpose or not. Okay, that is the one ML models we are going to use. So ML model contains, okay, okay, DLs. Okay, it's like a subset to my ML. It is like subset to my ML. DL stands for deep learning. Okay, last time we discussed about neural networks. Okay, how it is a kind of mimic the human brain. Okay, is nothing but, okay, just it is going to understand. okay, if I show something, one image, if I show to you, okay, either dog or cat, then that time simply you can say, hey man, this is dog, hey man, this is like a cat. So how it is going to tell, okay, how my model is going to tell that image is like which image classification it is, which kind of image means, by writing some DL algorithms, deep learning algorithms. So it is a kind of, okay, mimics your human brain, how my brain, okay, contains the neurals. In every neural stored something, whenever it is required, it is going to activate and it is going to tell some answers or not. Same like this here also, my deep learning model, okay, it is a kind of mimics your human brain. Okay, how you, if I show to you one cat image, how your brain, okay, just tell like, hey, it is a cat. Same like this, if I give the image to my DL model, my DL model also just it is going to tell this image is like what, cat or dog, something like that. So it's a kind of how my human brain is like thinking, same like this, okay, my model also thinking or not. Okay, it's a kind of DL, most of the times automatic cars, driving cars. Okay, it is like DL models only or not. Yes or no? So ML, DL. The next one is like these all are come under, okay, AI, artificial intelligence. Okay, it's a kind of how the human is like behave. Same like this, my model is going to behave. Okay, it's a kind of AI. AI is nothing but it contains ML models as well as DL models or not. So ML, DL is the subset to my AI. Okay, you are working on ML means yes, you are working on AI. You are working on DL means yes, you are working on AI. Now, these all are like, if you observe, work with the data only. Work with the data only. Now, if you add some mathematical concepts, okay, with this, okay, if you add some mathematical concepts with this, now you can say, okay, terminology wise, your role is like a data scientist. Data scientist. Okay, he is going to work with ML, okay, with some mathematics, okay, DL and AI, all. Okay, then you can say you are like your role is like a data scientist. So, what kind of mathematics we are going to use frequently? Okay, one is like, you know, about the terminology like linear algebra. Linear algebra. Did you hear about that? The next one is like probability. The next one is like probability. The next one is like statistics. Statistics. Okay. The next one is like calculus. Okay, just you can, okay, work with the numerical data. Okay, the next one is like optimization. Okay, linear and non-linear optimization. Okay, these are like first three is like frequently we are going to use in our, okay, data science. In our data science. Okay, linear algebra. Can anyone tell me here how this linear algebra, okay, in your mathematics, okay, what kind of concepts we are going to use in linear algebra? Okay, do you know about the terminology like vectors? Do you know about the matrix? Yes or no? These all are come under linear algebra only or not? So the vector matrix you said, so how it is interrelated with your data science? How it is interrelated with your, okay, you work with AI or ML or DL with some mathematics, I said like a data scientist, right? So how the linear algebra is, okay, work, okay, is implemented internally, okay, how the linear algebra in our data science. So very simple. You said like linear algebra is a kind of vectors, concepts like vectors, matrix, right? So for example, okay, come to the data wise. Okay, I have, okay, one student, some scores, okay, his marks there. Okay, his maths marks, okay, his, okay, science marks, something like this. Okay, one student is there, his data in mathematics, he got like 80 marks. In science, he got like 70 marks. 70 marks. Okay, this is data. It's like small kind of, okay, data representation for my student. Now if it is like a data, so how we can represent this data? Okay, in my matrix, if you want to represent, or in your vectors, if you want to represent, what is the difference between vector and matrix? Either single row, single column, we can say like a vector. Multiple rows and multiple columns, so we can say like a matrix or not. Now if you want to represent this data, okay, simply how we can represent? Okay, I can represent like, okay, one vector, something like this or not. One column, okay, just two rows. One column with two rows, something like this I can or not. Yes or no? One column with two rows. Okay, matrix, how it looks like? Just you can put like some square brackets or not. Okay, now see, okay, this particular data representation, how it is looks like? As like a vector. Okay, one column and two rows or not, something like this. Okay, 80, 80 and 70, just you can put it. Okay, how the vector is looks like? Okay, this is the one. Okay, just one square bracket you can put it. Okay, so one square bracket you can put it, something like this. One square bracket, how it is? Okay, something like this you can put. Okay, now I can say this is like what? One row, one column. You can say like a vector, right? One row and one column. You can say like a vector. Now see how many rows are there? Either one, okay, one column or one row. Here only one column is there or not? Here only one column is there. So I can say this is like what? One vector or not? Yes or no? Now, if you want to do some mathematical operations, for example, okay, now I want to know the average score. I want to know the average score, mathematics. Okay, okay, how we can do it? If you want to do the average score, how we can do it? 80 plus 70 by 2 or not? The same thing, okay, we can do it by using matrix multiplication also or not? Matrix multiplication. Okay, you know about the matrix multiplication. Average is nothing but just you can put like, okay, half, right? Okay, by 2 or not. So here simply I can do like matrix multiplication concept. Okay, first one 0.5 of 0.5, 0.5 and 0.5. Now simply I can do some matrix multiplication. Okay, you know how to do the matrix multiplication? Matrix multiplication, how we can do it? Matrix multiplication. Okay, just I want to find the average score. This is my actual score. This is like one column. Okay, now through matrix multiplication I want to find the average. So how we can do the matrix multiplication? Very simple. Okay, this row has to multiply to this particular column or not? 0.5. Okay, first one 0.5 you have to multiply to 80, then the time you can get like how much? 40 you can get it. Okay, now 0.5 you can multiply, okay, with 70, then the time you can get like
35.
35, right? Okay, now the average score is like how much? Okay, you can say the average score is like 75 or not. It's a kind of what? Matrix multiplication or not? Yes or no? Now for example, okay, another data set you can take it. Another data set, it's a kind of one column. It's a kind of one column. Vector is nothing but what? One row or one column or not? Vector is nothing but one row, one column. For example, I want to go with the matrix. I want to go with the matrix. I want to analyze, I want to represent some data in the matrix format. Okay, then you know, very simple. We have different OTT platforms, right? We have different OTT platforms. Okay, Amazon Prime, Netflix, okay, something like this. Different OTT platforms are there. Now in my OTT platform, there has thousands of movies we are going to, okay, we are like uploaded, okay, in future also, day to day, just we are going to upload our movies or not. Each and every OTT platform has, okay, thousands of users also, okay, not thousands, lakhs of users also or not. Yes or no? So that data representation I want. That data representation I want. Okay, by using linear algebra, the matrix concept, we can represent that data. So how we can do that? Very simple. Let's take like Amazon Prime. Now, as I said, number of users are there. The next one is like, okay, day to day, just we are going to upload like movies. Okay, so can I write, okay, user one, okay, user two, and user three, like this. There are hundreds, okay, so many users, you can say, so many users, okay, so many users we have. Now, number of movies also, right? Movies, okay, movie one, movie two, movie three, movie four, like this. There are so many movies are there, so many movies are there. Now I want to see, okay, today I just uploaded one of the movie. That movie is like an action movie. Okay, this user, okay, viewed that particular movie, so that I can represent like the user, okay, watch that movie. Watched that movie means just I can put like one. The user not watched, then that time just I'm going to put like, okay, zero. So movie one, watched by how many users? So user one watched, user two not watched, user three not watched. Same like this movie two, okay, no one is like watched, just simply. Okay, the next one is like movie three, okay, all are like watched, all are like watched. Now see the data representation, how it looks like. The data representation, how it looks like. There has multiple rows are there. At the same time, there has multiple columns also there or not. Yes or no? There has multiple rows and multiple columns are there or not. Okay, now this data representation is what? Rows and columns, what we can say? What we can say, rows and columns. Just we can say like a matrix or not. Okay, now, for example, movie one is like an action movie. Now I can understand like how many people are like watched. I can analyze the data based on that one in future. Okay, user one used most of the times. User one is like watching like action movies. Then that time simply, okay, based on my analysis, just I can understand like user one is watching only action movies. Okay, in future, any action movie is going to release, okay, just I'm going to promote something his, okay, on his dashboard, okay, somewhere I'm going to give some ads or not. Okay, this action movie is like, okay, releasing on this particular date. Okay, something like this I can promote or not, I can advertise or not, based by analyzing this data. Okay, user three or user two, only he can see like, okay, comedy movies only. Then the time any comedy movie in future I'm going to upload, just I'm going to promote or not. Okay, he is watching like only comedy movies. If I promote like action movies in his dashboard, there is no use or not. Yes or no? By analyzing this one, I can do something or not. This data representation, how it looks like. It's like a matrix format or not. Yes or no? Come on. Understood, right? So for any questions, anyone? Okay, linear algebra, it's like vector and matrix most of the times. Vector is nothing but single row, single column. Okay, matrix is nothing but multiple rows and multiple columns. Multiple rows, multiple columns. Okay, on this matrix, okay, this is one kind of scenario. In another scenario also, for example, there has, okay, the users are there, okay, they are paying some amount, okay, okay, user one, okay, this month, okay, it's just simply user one no month, you can say this month this much amount he paid, this month this much amount is paid, something like this. Okay, in the month of January, okay, the, okay, new year, okay, just I'm going to give the discount. Then the type, the discount is applicable for all the elements or not. Then the time what you can do, the matrix elements has to divided by, okay, some percentage, 20% of your current, okay, current subscription fee, something like this we have to do it or not. Yes or no? If it is like a structured in the matrix, I can do any operation on all elements or not with a single formula. Agreed? Okay, this is about linear algebra, matrix, and vectors. Okay, the next one is like probability. Tell me, probability. Probability. Okay, it's completely machine learning, you can say. Okay, it is like data analysis. Okay, probability most of the times using in the machine learning. Machine learning already I said, right? Machine learning. Okay, what I said? Machine learning.
Prediction.
Yeah, prediction, right? You read the current data, and predicts the future or not. Predict the future or not. Yes or no? For example, you can take probability. Probability example, simple example. Can anyone tell me? There has multiple students over there. Okay, there has 100 students over there. I am the faculty. I thought like, okay, there is a probability of passing. Okay, 80%, 0.8%, 0.8. Probability of passing is like 0.8, and probability of failing is like 0.2. Okay, okay, percentage you can say like 0.8 to 80%, 8%, something like this. 8 means 10. Okay, 0.8 means 1 it is going to take. Okay, 80 means it is going to calculate on 100 or not. 100 or not. Okay, I have multiple students over there. The students passing probability is like what? 0.8 or not? Okay, the students fail probability is like what? 0.2 or not? Okay, now there is 100 students or there is multiple students or there. For example, here it's like 10 students, 0.8 I take it, right? Okay, there is 10 students or there. If I pick randomly two students, what is the probability of passing those two students? What is the probability of passing of those two students? There are 10 students are there. I said like probability of passing how much percentage? 0.8. Failing is like 0.2. Now my question is like, if I pick like two students randomly, what is the probability of passing these two students? Probability. Both passing. Okay. Simply the pass percentage there, nah? Okay, pass percentage you can do like square 0.8. Okay, now tell me how much? 0.64. 0.64. So this one is like randomly if I pick, this one is like what? Randomly if I pick, okay, the pass percentage is something like this. Okay, so probability most of the times what? Probability most of it's a kind of prediction only, right? Not exactly we are going to tell. Okay, it's a kind of prediction kind of or not. Yes or no? Agreed? Okay, the next one. Another one also. There has 10 students or 5 students or there. 5 students. I want to pick the 2 students. How many ways I can pick the students? I want to know how many ways you can pick 2 students from the class to his like 5 students. 2 students I want to pick. 2 students I want to pick. Okay, from come on, from how many students out of 5 students or not? Okay, the probability. It's like a discrete mathematics. Tell me. I have overall 5 students are there. I want to pick 2 students. Tell me the probability. How many ways I can pick students? 2 students. Student 1, student 2. Student 1, student 3. Student 1, student 4. Student 1, student 5. Student 2, student 3. Student 2, student 4. Student 2, student 5. Something like this or not? Probability can find it or not? Yes or no? Okay, how we can find it? Okay, very simple. The formula is like overall how many students are there?
N into n minus 1 by 2.
Okay, n factorial by
Correct.
n factorial by, okay, this is okay, here you can write, okay, 5 directly you can write 5 factorial by, what is that?
5, 5 minus 2, sir.
Okay, yeah, 5 minus 2, 5 minus 2 factorial, right? Yes or no? This is the formula, right? So overall how much you can get it? 5, 4, next 3 factorial, right? 3 and
2,
okay,
1.
1, that's okay. Now
1
here
and 2 factor
is
2,
there 2 into 1, that's okay. The next one is what? 5 minus 2, 3.
3
Three.
into 2.
3 and 2, no? Yes or no? The probability is what?
3 to
10, right?
Yes, 10.
10 or not? Okay, so the total combinations are like what? Okay, 10 ways you can choose or not. Yes or no? Got my point? The probability. Same like the statistics are there. Okay, why we go for statistics? It's also data analysis. Okay, it's also we are going to analyze the data or not. Okay, here okay, most of the time these concepts we are going to use. Statistics things we are going to use. Okay,
Class alternate.
yeah. You know the types of statistics.
ఏమైంది ఇక్కడ
Types of statistics.
కింద
Anyone?
పడ్డావా
mean,
ఎక్కడ
median,
That is like median, mode, variance. Okay, standard deviation. These are
variance,
okay concepts. Okay, type of statistics. One is like inferential, inferent. Another one I don't know this. Inferential. Another one is like descriptive. Okay, one is like inferential. Another one is like descriptive. Okay, which one we can say like a inferential and which one we can say like a descriptive? Okay, first of all, statistics dealing with what? Okay, data only, right? Okay, so first what we need to do if you want to deal with the data, if you want to dealing with the data, what we have to do? You have to collect the data, right? First, you have to collect the data, and then what you need to do? You have to analyze the data, right? You have to collect it and you have to analyze it or not. And then you can do what? Okay, you can, okay, predict something based on this particular data. You can predict something. Once it is done, okay, whatever the prediction is there, you have to show it, right? You have to do the presentation or not. Yes or no? You have to show the presentation or not. Okay, basically the statistics work with data only. First, data wherever it is, you have to collect data collection. The next one is like you have to analyze the data or not. You have to analyze the data or not. Okay, the next one is like what? You have to do something. You have to predict something or not. We can say terminology wise interpretation or not. Interpretation or not. Once you did it, you have to show it, right? You have to do what? Presentation or not. You have to presentation or not. These are the things, right? Okay, now if you come to the types of statistics, if you come to the types of statistics, one is like okay, inferential statistics, another one is like descriptive or not. You can say like inferential statistics. Anyone? Inferential statistics, which one we can say? Okay, very simple. So you can take, for example, we have like, okay, some polls, right? Okay, polls is nothing but, okay, once our elections completed, okay, exit polls, they are going to release or not? Exit polls. Okay, how they are going to do that? How they analyze? Okay, some of the, okay, organize, okay, some of the people are like do, okay, this in the background, some, okay, analysis, and they are going to release the exit polls or not. Okay, there this party can get, okay, these many seats, this party can get these many seats, something like this. They analyze and they are going to tell or not. It's a kind of prediction only, it's not like exactly. Okay, how they do, in the background. Okay, in the assembly, okay, constituency, there has 2 lakhs voters over there. Okay, will they go and each and every voter they ask, hey, you voted for which party, something like that? Is it possible? Tell me first.
No.
No, right? No, right? Okay, they are going to pick like it is completely entire data collection is like impossible or not? Entire data collection is like impossible or not? What he is going to do? Okay, they are going to take like a subset of the data. Subset is nothing but what? 2 lakhs waters are there. Okay, 2 lakhs water. One of the water is subset to 2 lakhs water only or not? Yes or no? Okay, in my constituency, I am 1 water. Okay, among 2 lakhs waters. I am what? Subset to the 2 lakhs waters or not? Yes or no? So that what they are going to do? Okay, the total entire data collection is not possible. Okay, it's like impossible. Hence, what is they going to do? A subset of data points they are going to collect or not? Okay, they collected like some samples. Terminology wise, we can say like some samples. Okay, there has one district is there. Okay, one constituency, one mandal is there. They are going to collect like 100 samples, 1000 samples, something like that. They are going to collect some samples or not, and they can get like some conclusion about the entire, okay, 100 samples. So just I analyzed and they concluded like what? That samples result they concluded for 2 lakhs waters or not? Yes or no? One. Okay, that kind of analysis we can say like, okay, that kind of analysis come under, okay, inferential. Come under inferential. Understood or not? Okay, wherever the huge data is there, this is not possible to collect each and every data point or not. Entire data is not possible. It's completely impossible. Okay, that's true. Okay, everyone knows. So that what they are going to do, okay, through this inferential statistics, they collected the subset of data. They collected like what? Subset of data, 2 lakhs waters only. They collected like some samples data and they analyzed that one. Based on that result, okay, they are going to put like what? They concluded for what? Entire data set or not? Yes or no? Got my point? Okay, this kind of statistics we can say like a inferential statistics. The next one is like descriptive statistics. Now you said like descriptive statistics, you have some data is there. Okay, I want to summarize the data. Okay, such I want to find the median, I want to find the mode, I want to find the standard deviation, I want to find the range, variance, all these. Okay, if you work for that, then you can say like what? That is kind of descriptive or not. Understood? One. Agreed, everyone? Okay, now tell me, you said like mode. Okay, this one is okay. Okay, how we can write the models and everything? Okay, at the time of data science, okay, we have different models over there. Okay, for this, okay, just by using that, we can, okay, collect some data points randomly and you can predict the future. Okay, you can predict the value and conclude that value to the entire data set. Like that, you have to create the model in future. Okay, this is like inferential. Descriptive, tell me. Descriptive. You said like what? Terminology wise. Somebody told. Mode. Next.
Median.
Median. The next. Mean
Lane.
also there. Na? Mean. Okay, the next one is like
Variance.
range also there. Range. Okay, the next one is like
Standard
standard
deviation.
deviation. Okay, the next one is
Variance.
like variance. These all are come under. These all are come under which descriptive or not. What is mode? Okay, by using this descriptive statistics, what we can do, it is going to identify, we can find the data set, how it is like distributed or not, how it is like distributed, we can find it. So mode means mode in my data set to which value you frequently observe, which value it is like frequently observed, that value we can say like a mode or not. Yes or no? I have a data set is there, okay, which is related to student weights. Okay, I saw like 100 students, so most of the students weight is like 60 60 60 60 something like that. Okay, which value you see frequently, most frequently observed, that value you can say like what, mode or not, that value we can say like a mode. Okay, the next one is like median is what, median.
Find the middle value of the value.
Yeah, you have to place your data in one order, weights only you can take. Okay, just you have to place the order in the order, either ascending order or descending order. Okay, the middle one we can say like what, a median or not. Okay, sometimes if the middle is like, okay, the total is like even, the total data set members are like even, how we can get the median? Okay, by 2 or
Find
not.
the average of
One, okay, middle 2 points you can take it, divided by 2, then you can get like what, median or not. Yes or no? N plus 1 by 2, the middle one, after the next one by 2 or not. What about the mean?
and
The
the
mean.
average.
Okay, it's a kind of average, right? It's a kind of average or not. Okay, sigma x by n, the formula is everyone knows, right? The total members by, okay, the total by total members or not. That one we can say like a mean or not. What about the range? Range is
How many
nothing but,
numbers are there?
okay, it's a kind of, okay, first 3 is like mode, median, most repeated. The median is like middle one, it's like an average. Okay, the next one is like what? Okay, range. It's a kind of min and max value difference or not. Okay, just you can place your data set in the order. Okay, the min and max, the difference we can say like what? The difference we can say like what?
Range.
Range or not. What about the standard deviation? Standard deviation is tells like what? It tells like what? Standard deviation, okay, it tells like what? It tells like, okay, how the next value is like spread, right? It tells like how the next value is like spread or not. Okay, do you know the formula? Do you know how the formula is looks like? Standard deviation formula. Square root of sigma, okay, the number minus your mean whole square by number minus 1 or not. That means n
First,
minus,
we have to find
yeah,
average,
yeah, you have to find the average first. Okay, after that,
and then it multiply to that we all values.
yeah, multiply. Okay, okay, just you can get it from here. Okay, here we are not able to write. can say some example. You can say this. Your data set is something like this. First of all, you have to calculate what? Okay, X bar is nothing but your mean.
Average, like.
Yeah, that is, you can say like an average you can take. Okay, now the first value minus average, second value minus average. Okay, after that, finally, what you can do? Total members of total members. Okay, n is nothing but total members. N minus 1 you can take it. Now here, if you come here, n minus 1 is like what? 6, right? So you can say like what? The final value is like the 7 or not. So the finally the formula is this one, right? The square root of sigma. Okay, xi is nothing but what? The values. Okay, x bar is nothing but what? Your mean. Okay, by n minus 1. So finally you can get this value or not. Okay, now this is the prediction only. This is the kind of prediction only. With that formula, what is the value you can get it? Same value. Okay, it is like okay, small. Okay, little bit changes may be there. For example, 0. I predicted like 0.4. Okay, through formula I may get it like 0.45. That kind of small. Okay, small changes are okay. But through machine learning model, if I predict something, okay, whatever the value I can get it, with this formula also I can get the same value. With this formula also I can get the same value. Okay, at the time of ML, okay, we can compare it. Through mathematics, whatever the formula I can get it, okay, by calculating manually, whatever the value I can get it, through machine learning model also, the prediction value also you can get like same. Okay, in the okay, there may be chance of like what? Okay, there is a difference in points, 0.1 or 0.2, something like that. But you can get the same value. Got my point? So mathematics, manually you can do it. The same work, the same prediction, I can do it by using ML model. ML model, whatever the value I can get it, I can compare with this formula so that I can get what? Okay, same value. I can get like a same value. Understood? Agreed? So the different types of okay statistics, high level, it is a kind of what? Okay, inferential. Another one is like a descriptive, we can say. Inferential data. Another one is like descriptive. The next terminology is like outlier. Did you heard about that terminology? Outlier. Okay, both are come under standard deviation, variation. Both are come under same. Okay, outlier. In anyone? Okay, the variance. Okay, square root. Then the time it's like a standard deviation. Whatever you find up to here, that one we can say like a terminology wise variance. Okay, the same formula one. Square root, if you put it, that is like a standard deviation. Okay, if you not put like square root, the value you can say like a variance. What about outlier? Did you have about that? Terminology wise, anyone knows? Okay, very simple. It's a kind of normal value only. Okay, which is like very far to the actual data set. Okay, very far from the actual data set. How you know? Okay, these are my students. Okay, data. Okay, students marks. Everyone get like okay 70 marks, 60 marks. Okay, in between. So many people get like 70, 60. Okay, 80. Okay, 50. Something like this. Okay, one guy get like only 2 marks. Another guy get like 100 out of 100. Now see. Okay, these values we can say like a outlier values. Okay, actual all the students the data in this particular only or not, in this particular range only or not. But one of the student got like 2 marks, so it is very far from the actual data set or not. Yes or no? Okay, this one also what? It is also very far from your actual average data or not. Okay, this kind of values, terminology wise, we can say like a outliers. Okay, this kind of data also you can take it while cleaning the data, just instead of take these values, okay, just we can take like average or something like that. Okay, in your pandas, most of the times we see this kind of different data sets. So while analyzing, okay, you can do some data manipulations. That time we can do something like this outlier values. Okay, it is like affected entire data set or not because of this 100, because of 2. Whenever you do the average, then the time it's like most of the times it's affected or not. Yes or no? So outlier values they are going to manipulate. How to manipulate at the time of pandas we can see. But outlier is nothing but the value which is like very far from your actual data set or not. That kind of values we can say like a outliers. Understood? Agreed, everyone? So for anyone have any questions? Okay, the next one is like variables, dependent variables or there, independent variables or there. Anyone knows? Dependent, independent variables are there. One is like dependent variable, another one is like independent variable. Anyone knows?
I think regression concept like regression, like linear regression.
Okay. Let's take like one simple graph. Okay, you can understand. Okay, just I want to draw one graph. Okay, something like this. Okay, here the age I'm taking on x-axis. Okay, the age I'm taking like on x-axis. Okay, 1 year and 10 years. Okay, next one is like 20 years, something like this. 20 years and 30 years. Okay, something like this. The height, okay, I can say like, okay, 2 feet, 4 feet, 3 feet, 4 feet, 5 feet, something like this. I added. Okay, now just I want to draw one graph. Okay, if it is like yes, okay, something like this from here, something like this based on the yeses. Okay, something like this. Okay, it is like right. So here, how many variables data is there? How many variables data is there? One is like this is age, right? This is age. Okay, and this one is like my height. Okay, there are two types of variables are there. Okay, I said like dependent variable, another one is like independent variable. Okay, dependent variable, another name also there, response variable, explanatory variable. Independent means, okay, just terminology wise in our own words you can say like a dependent, independent. Now tell me, okay, two variables age and height is there, which one is like dependent, which one is like independent? Which one is like dependent and which one is like independent?
I think age is independent.
Yeah, my age is like independent, right? This is common. Age is like independent. It is not changed. But the height is like what? Depending upon the age or not? Yes or no? Okay, now based on these particular values, so for example, if I said like my age is like 40, I can predict my height or not. I can predict my height or not. Okay, that prediction I can do through ML. Okay, at the same time, okay, I can do it programmatically, mathematics. Manually, I can do it through our formulas also or not. Whenever you do through ML, through formula, whatever it may be, okay, finally you can get the same kind of output only or not. Understood? Agreed? Okay, the next one is like terminology was regression. Did you heard about this one? Linear regression, I said, right? Regression. Regression. What is regression? Okay, regression is nothing but you know that one. Okay, it's a kind of, okay, how we can draw a line in between the points. How we can draw the line in between the points. Okay, this line represents what about the, okay, something like this data is like above the line, this data is like below the line, something like this. We can do it or not. Now, okay, let's take this one only. Okay, you can take x-axis and y-axis. Terminology wise, just you can remember what is regression means. Okay, draw the line in between the data points. Draw the line in between the data points. Now I have, okay, this is my x-axis and y-axis. There is multiple points, just I added. Okay, something like this. Okay, I added. Something like this, I added. Okay, here I have the dependent variables are there. Here I have the independent variables are there. Based on that one, just I added. Now, in between the points, if I draw one line, something like this, this line, how we can draw? Okay, this line tells something about the pattern of your data. Okay, above something, okay, below something, I can classify the data or not. This line, we can say like what? How we can draw programmatically? That is
Using
mathematical, I can say. Okay, we have one formula is there, y equals to mx plus c. Did you hear about that? Yes or no?
Yes, sir.
Y equals to mx plus c. Yes or no? Okay, by using this one, okay, we can draw the line or not. We can draw the line or not. Once you draw the line, okay, what we can classify? Okay, on the above line, okay, we have some data is there. Okay, we can, okay, classified. For example, age, you can take it. Okay, age, weight, you can take it. Okay, if they draw the line something like this, okay, in this particular age, okay, you can say like in this particular age, okay, how many people are, okay, you can classify the weight, average weight. For example, my age is this one, that people average weight is this one, my age is like below this one, my people average weight, something like this, we can classify or not. Okay, here y equals to mx plus c is there, right? What is this m? Okay, we can say like a slope. What is this x? The value, right? The dependent. The next one is like, what about the c? It is like intercept, you can say. It is like a intercept, you can say. Okay, once you have these values, so we can find that y value or not. Yes or no? Okay, you can take one simple example there. If you study 1 hour, if you study 1 hour, okay, you can say like a study time. Okay, you can say it is like a time. Okay, now you can get your score, GPA, something like this. You can say your score is like 2 point, you may get like 2.0. Okay, na? If you study 2 hours, your GPA is like 1.5. If you study 3 hours, your GPA is like okay 2.5. Okay, here one okay you can say 0.5 or something like that. Okay, we can change it like that. Okay, 5 hours if I study, okay 3.6.5 something like this. Okay, study time and your value. Okay, 10 hours if I study. Okay, that is like not like always increase. Some people study 10 hours, they may get like less also. Okay, we have okay. This is my data. Okay, time and my GPA or not. Okay, now I want to predict a student GPA from the amount of time. Okay, how much he spend or not. How much time he spend. So what we can do here, if you want to draw the graph, okay, how we can draw? I have the time and my student GPA. Which one is like independent? Which one is like dependent? Which one is like independent? Which one is like dependent? My time is like independent, and my which one is like dependent? My GPA is like dependent or not? Yes or no? My GPA is like dependent or not? Yes or no? Now I want to okay put some points, right? Yes or no? Now 1 hour if I study, okay, they can get like okay this much GPA. 2 hours if I study, I can get like this much GPA. Okay, one person is like studied okay 5 hours, but he get like this much only. One person get it like this. We are going to do what? Add some points or not? Yes or no? We are going to add some points. Okay, what is the next one? Now the regression. Okay, regression is nothing but what? You have to draw the line. Come on, you have to draw the line in
Using the
between
point.
the points or not. You have to draw the line in between the points by using which formula? Y equals to mx plus c. That formula we can use it or not? Yes or no? Okay, so how we can get those values? How we can get those values? Come on, how we can get those values? M is nothing but your slope. Okay, some inputs you can get it. Okay, C is nothing but what? Come on, C is nothing but what? Okay, here I can get it something like this. I have student study hours and GPA need to draw the regression line using y equals to mx plus c. Calculate the value using that. Then the time you can get like y value. Y equals to mx plus c. Now just wait. Now you can say this. Whether has study hours and GPA. Okay. Now once you have this GPA and everything, you will they draw like what? They draw like one line or not. So here my study hours are like what 508 this one, and my GPA is like okay 2.5, 3.5 something like this. My regression is like what? The regression line is like mx plus c is the formula or not. Okay, my slope Okay, m value, my intercept is this one. Okay, now mx plus c. Okay, the predicted GPA approximate is like for 11 hours, so you can get like what 3.59 using this formula. Okay, if you write like, if you give like an input for 11 hours, you can get like what the GPA is like 3.59 or not. Okay, this is the prediction through the formula, but using ML model also you can get the same kind of, output. Okay, here if this x value is there now, this x value keep on changing. Okay, for example, my x value is like 20 hours, then the time you can get like what some approximate GPA, you can get it or not. Yes or no? Agreed? Programmatical, how we can. Any questions? Okay, this is like a regression. Okay, most of the times regression also we are going to see. Okay, in our ML. The next one is like the data once you have, okay, we are going to visualize the data also or not. Visualize the data means what? Okay, already, okay, in the statistics, you have the data and you analyze the data, and finally you have to visualize the data or not. In the statistics you have to show, right? So how we can show the data, visualize the data? How we can?
Graphical.
Okay, through graphical representation or not. Through graphical representation or not. Okay, either, okay, my graphs are like what? Either my graphs are like line graphs, either my graphs are like sometimes, okay, it's like a bar graph or something like this or not. Okay, tell me one simple example for line graph with your data. Okay, just tell me, okay, when you can go with the line graph, the data visualization wise. Data visualization wise, okay, when you can go. Okay, you can say like two variables are required. One is like dependent, another one is like independent. My dependent variable, for example, my data set is like this. Okay, my day and earnings, okay. Now if my day is like Monday, my earning is like 400. If my day is like Tuesday, my earning is like 500. If my day is like okay, Wednesday, my earning is like 251, something like this, 251. Okay, now I want to represent this data. Then how we can, which one is like dependent, which one is like independent? My independent is like days, right? So here I can say like a, okay, day. Here I can say like what, earnings or not. Okay, then the time, okay, on my first day, okay, I earned is like 400. The next day 500. Okay, the next day is like 250. The next day something like this, we can represent the data or not, the graphical representation. Yes, no? Yes or no? Okay, now sometimes we can do like what, sometimes we can do like multi lines also. Then the time what you can do.
Boxes.
Okay, now Monday my earnings are this one. The expenses, for example, okay, one more. My expenses are like 150, for example. Okay, now Monday, okay, Tuesday 500. My expenses are like 200, okay, or 300. Then the time one line for what? One line for my earnings. Another line same day. Another line same day. Okay, is representing what? My expenses or not. Something like this also we can do it or not. In a single graph you can write like any number of. The next one is like bar graph also. Give me one example for bar graph.
Code, like
Okay, how it is like representing the data. Okay, you can take like x coordinate and y coordinates, just you can represent the data bar. Tell me, my student two and their marks, right? Okay, one subject is there, he got like Okay, one subject he got like, okay, once, okay, in the first year he got like, okay, this much GPA. Second year he got like this much. Okay, third year this much only. Okay, can you predict the future? Okay, that means fourth year how much you can get it? Okay, like this we can data representation, we can do it or not? Yes or no? Okay, there is two vertical graph, vertical bar graph like this. Okay, the next one is like horizontal. These bars only like this also we can do it or not? Yes or no? Sometimes double bars also there. Double bars also. Okay, simple. Last one only you can take it. Okay, Monday my earnings are this one and my expenses are this one. Tuesday my earnings are this one and my expenses are this one. Okay, Thursday something like this. Okay, Wednesday something like this. Thursday something like this. We can do multiple graphs something like this or not? Double bar chart. Yes or no? Okay, next one is like okay, box plot also there. Okay, at this moment, okay, you may not understand that one. Okay, scatter plateau, box plot, okay, box chart, okay, box plot, scatter plot. Okay, like this, different charts are there. We have one library is there, matplot library and Seaborn. Okay, by using that one, we can do pie charts also there, pie charts also, something like that. Okay, this is like a visualization. Understood? Okay, internally we are using these mathematics, but in the back, in the foreground, while writing, while doing the data science, these directly we not use, but internally these mathematics they used. Got my point? In the data science. Agreed? Okay, this is like high level. Okay, in the data science course, okay, we can get some more examples. Okay, we can run the formulas and we can run our model. My formula and model both we can compare. Okay, they will give the proper output, the same output or not. This kind of checks also we can do it. Understood, everyone? Got some idea?
Yes, sir.
Okay, for now we can stop. Okay, remaining things we'll see in the next session. Okay, then thank you guys. Thanks for joining. Any questions?
Yeah, next Gen AI session is the right 1 month. That is also starts from here, right, sir?
Yeah.